Here we will see series in Pandas. A series is a one-dimensional array-like structure with homogeneous data and are capable of holding data of any type, that is integer, string, float, Python objects, etc. The values of the series are mutable, that is we can change any value in the series, but the size of the series is immutable, that is we cannot change the size of the series. Series are like a single column of an Excel sheet or a column in a table. We can create series in two ways. First, create an empty series or create a series using inputs. General syntax for creating series is pandas.series with parameters data, index, dtype and copy, where data takes various forms like ndarray, list, constants. Index values must have the same length as data and is hashable. If no index value is specified, value ranging from 0, 1, 2 up to n-1 are by default. Dtype is used to specify the data type that will be stored in the series object. If it is not specified, data type will be inferred. And copy accepts a boolean value as input which is set to false by default. It is used to determine whether or not replicate the input data. First we will see creating an empty series. We can easily create an empty series in Pandas using the syntax series object equal to pandas.series. This syntax will create an empty series that has no values, but the default data type is float64. For example, if we use syntax import pandas as pd, x equal to pd.series, and if we print x, it will create output as series, empty series with dtype as float64. We can create a series by using various inputs, that is array, dictionary or scalar value. First we will see creating series from array. Before creating a series, firstly we have to import the numpy module and then use array function from the np array. If the data is ndarray, then we have to pass the index of the length. For example, here first we will import the pandas, then we import numpy and we will create numpy array with data as pandas, and then we will create series as pd.series for this array as info, and when we print a, that is series, it will give the output as, it is for 0th index it will print p, for first index it will print a, for second index it will print n, and so on, and the data type will be object. Then we will see creating a series from dictionary. If the dictionary object is passed as an input and the index is not specified, then the dictionary keys are taken in a sorted order to construct the index, and if the index is passed, then the values corresponding to a particular label in the index will be extracted from the dictionary. For example, here we have first imported the pandas, then we have imported numpy, and we have created a dictionary as x with value 0, y with value 1 point and z with value 2 point. And if we create a series with this dictionary info and if we print it, it will print the output as x with 0.0, y with 1.0, z with 2.0 and data type will be float64. We can create a series using scalar value also. If we use the scalar values, then the index must be provided. The scalar value will be repeated for matching length of the index. For example, here we have imported pandas and numpys and we have created a series with scalar value as 4, index is 0, 1, 2, 3. And if we print x, it will give the output 0th index it will print 4, then for first index it will print 4, for second index also it will print 4, and third index also it will print 4, and data type will be int64. Advantages of using series are: series uses labeled indexing, that is series give classified indexing, making data access and manipulation initiative and efficient. Homogeneous data. Series holds homogeneous records, resulting in memory performance and constant data type operations. Element-wise operations. Series supports element-wise operations, which simplifies statistical transformations and calculations. Time series handling. The series is well accepted for managing time collection statistics with timestamps or date-based total indexing, and data alignment. Series itself aligns data based on the index labels, ensuring correct operations. Now we will create a series in Jupyter Notebook. Since we are using Jupyter, no need to install the pandas here. Since we are using Anaconda, the pandas are default installed in the Jupyter. First we will create empty series. First we will import pandas and we will create series as x equal to pd.series and we will print x, and if we execute it, it will create a blank series with data type float64. Now we will create a series with arrays. First we'll import pandas. So import pandas as PD. Then we'll import numpy. So import numpy as np, and we'll create an array as info equal to np.array with values, and we will create series as x equal to pd.series for info, which is an array name, and we'll print x, and if we execute, it will create a series. Since we have not defined the index values, the index starts from 0. So for 0th index, it will print p. For first index, it will print a, and so on. Now I'll create series with dictionary. Here we have already imported pandas and numpy. So I'll directly define a dictionary. So d equal to, we'll create dictionary as curly bracket. First is x and value will be 1. Then y value will be 2. And z value will be 3. Then we'll create a series as x equal to pd dot series with d, which is a dictionary name, and we'll print x, and if we execute, it will print x with 1, y with 2, and z equal to 3, and the data type will be int64. If I give here 1 point, 2 point, and 3 point, and if I execute, it will create series with x as 1.0, y as 2.0, and z as 3.0, and data type will be float64. Now I'll create series with scalar value. So x equal to pd dot series with value as 4 and index equal to 0, 1, 2, 3, and if we print x, and if we execute, it will print a series as 0th index 4, 1 index 4, second index as 4, and third index as also 4. Here 4 is a default value set. If we give here 3, and if we execute, it will display the value 3, and if we add one more index here, and if we execute, it will add 4th index also with value 3.